In our last example, we took the f of x and g of x functions and added and subtracted them. In this example, we're going to go ahead and multiply and divide those same two functions. So I've started the first part, the multiplication. I've written each function in parentheses being multiplied together, and to do this we've multiplied stuff like this before. To do this we can either use FOIL, we can distribute, or what I like to do is I like to use the box method to multiply. So whatever method you prefer, let's go ahead and multiply these two binomials together. So using the box method, if you're going to do this like I did, I'm going to write my terms outside the box, and then multiply each row and column together. So 4x times negative 9x is negative 36. X squared, you'll start changing your exponents, adding your exponents when you multiply. 3 times negative 9x is negative 27x. And then let's keep going, let's do the bottom row. So 4x times 5 is 20x. And then finally 5 times 3 gets me 15. So to finish this, then I'm going to go ahead and add up any like terms I have in that box to get my final product. So negative 36x squared. My like terms, my only ones I have are with the x's, so right there. 20x plus negative 27x is negative 7x. And then finally that plus 15 just goes down as part of my answer. So there's the product of those two functions. Okay. My last step, what they asked me to do is divide. They want me to divide these two functions together. So what I'll do for division is rather than have that divide symbol, I'm actually going to turn that into a fraction bar, because that's what fraction means. It means to divide. So this time they want to do f of x divided by g of x. Well, in some ways, the division ones are the easiest of these problems. F of x is this 4x plus 3. I'm going to divide that by the g of x, which is negative 9x plus 5. And the reason I said some of these division ones are the easiest ones is at this point, that's it. That's as far as I can simplify this. From our last unit, you may recall that the only thing we could try to do is we could try to factor our numerator or denominator in order to cancel out common factors, and nothing factors this time, so nothing can be done with that. However, there is one extra thing I'm going to want you to do with these problems, and that is there's one number we never wanted to divide by. And if you remember what that was, we never ever wanted to end up with a 0 in the bottom of these fractions. And so what I'm going to do is I'm going to, after I have my actual function, that's what I get when I divide, I want to do one extra thing, and I want to add on to this what x is not allowed to be. There's one number that x can't be. And in this case, I might not know off the top of my head. Sometimes we could just look and know, and this time I don't really know. And so if that's the case, here's what I want you to do. Take whatever that denominator is, negative x plus 5 in this case, negative 9x plus 5, and set that equal to 0. And let's figure out what would make the bottom 0, because then we'll know what x cannot be equal to, if that makes sense. So let's solve this little mini equation then to find out what's the one and only number we would not want x to be in this case. So I'll subtract 5 from both sides. And then if I divide by negative 9, the only thing I can really do to simplify negative 5 over negative 9 is make each of those numbers positive. And so I find out that if I made x 5/9, I would end up dividing by 0. If I plugged in 5/9 for x, that would be really bad. And so then going back to my original problem, in addition to saying that this was the function I get when I divide, I also want to say that x cannot be equal to 5/9. That would be really bad. It would mean I'm dividing by 0. So in some ways, the division ones are really easy. In other ways, they do have this extra step involved.